We have to focus on the fact that it works for both radicals and for imaginaries. So our conjugate root theorem says, if you get an a plus the square root of b, it's never alone. It always has a little puppy dragging along behind its heels, and that's going to be a minus the square root of b. So always in pairs, square roots and imaginaries. If we have a plus bi, a minus bi is there, because the quadratic formula tells us plus or minus. Those two pieces have to be there. So we want a graph to do what we want it to do. In order to make everything happen that we want, we have to understand that sometimes you're going to have to put imaginary zeros in something. You don't want it to cross the x-axis, but you need it to be a fifth power polynomial. So then you have to realize, oh, I'm going to have to use a couple of imaginaries. It's the only way I'm going to make that work. So this one says we've got a quartic, and one of the zeros is the square root of 2, and the other one is 1 plus I, and those are roots. Well, that's not enough. We know that. Quartics are supposed to have 4 of them. But now, if the square root of 2 is there, what also has to be there? Negative square root of 2. Has to be. They always come in pairs. And if 1 plus I is there, what else is there? 1 minus I. Get the phones put away so I don't have to put them into the cell phone jail over there. All right, this one says we've got a cubic. How many zeros does a cubic have, everybody? 3. Cubics have 3 zeros. A cubic polynomial has real coefficients 3 minus 2i and 5 halves. Those are 2 of its zeros, 2 of its answers. We need one more. What's the other one? 3 plus 2i. Remember, imaginaries and irrational answers, which means it has a radical and you can't get rid of it. Always come in pairs. The other ones can come one at a time. The 5 halves, that's fine. That's 2.5. That's a good answer, you know. But the other ones, the nastier ones, they always come in pairs. Aren't we lucky? It's always a 2 for 1 with the nasty ones there. 2 for deal. Alrighty. So here's what we're going to do. We're going to take our wonderful zeros and we're going to write a polynomial so that we know what it's going to look like when it all comes together. So if they tell us the zeros were 5 and negative 2, we work backwards and say, well, for this to be 5, it had to come from x minus 5. And for this to be negative 2, it had to come from x plus 2. That's not a big deal. We'll just multiply those two together with FOIL. X squared minus 3x minus 10. And there it is. So what we're going to do today is focus on how do you write these. And what I want to do is go over the tougher one with you and then hand you one that's a little bit easier. So I'm going to wait on this multiple choice one. And let's go down here and do the little bit tougher one first. All right, everybody, it says quartic polynomial. What does that mean to you? 4 zeros. What quartic polynomial equation has roots of negative 3i, 8, and 2? I think we're short one. What's the other one? If these are the 3 zeros they gave us, what's the other one? Positive 3i. Huh. Let's take a peek at this. We have to call it a function because it said quartic polynomial equation. So let's do f of x equals. Now, I'm going to do the easy ones first. If it's 8, it must have come from x minus 8. So that's got to go here. Because it's always x minus a, whatever that is, for a factor. So if it's 2, what parentheses do I need for the 2? X minus 2. All right, so those were the nice ones. Now we got the ugly ones. Where'd they get the 3i and the negative 3i from? Think just like these. X plus 3i and x minus 3i. Now, Colin, in a way, of course, you're right, because they did. It was square root that got them my stuff. But don't think that deep with this one. Think, okay, I just got to put it back in the parentheses. That's all I have to do. Now, most of us, we're going to squirm at those last two. And we're going to say, I want to wait till last to do those two because I don't like them. Resist that impulse. Go after them right away. Because if you multiply those two together, you're going to get something nice. And the rest of the problem gets much easier. So, tell yourself, I can do this. I'm brave. I'm going to multiply those two together first. Yes. I've got this. So, first times first would give me x squared. That's not an issue. Outside times outside, negative 3ix. Inside times inside plus 3ix. Hey, what's going to happen to my ix's? They're going to be gone. And that's because one's a plus and one's a minus. So in the next one, you wouldn't even need to write down your two middle terms. You know they're going to cancel out, so what's the point? And then you say, okay, I need 3i times negative 3i. That's going to be negative 9i squared. All right, so right now I've got x squared minus 9i squared. Wait a minute, don't we know what I squared is? What's I squared? It's negative 1. So if this is negative 1, this is really going to be negative 9 times negative 1. That's plus 9. And now it's nice. So if you put the two imaginary ones together and multiply them, things end up nice. And now we just need to get our little x minus 8 and x minus 2 back into the picture. And I'm pretty sure we already know how to multiply those. So let's do FOIL on those two. See what we get. First times first is x squared. Outside times outside is negative 2x. Inside times inside is negative 8x for a grand total of negative 10x. And then negative 8 times negative 2 plus 16. And now I don't know about you guys, but I usually like the shorter one in front. So I put the x squared plus 9 in the front so I can do the clamshell. You could do it the other way. It doesn't make any difference. But you have to make sure that everything in one set of parentheses gets multiplied by everything in the other set. So clamshell in this, we're going to need x squared times all three terms. That will give us x to the fourth minus 10x to the third plus 16x squared. And then 9 times all three of the terms. So plus 9x squared minus 90x plus 16 times 9, 4, carry the 5, 144. Done? Well, what else could we do? Yeah, we got to combine like terms if there's any of them. X to the fourth minus 10x to the third, but we have 16x squared and 9x squared for 25x squared minus 90x plus 144. So it turned out the only like terms we had were the x squared terms. Beautiful. So here's what's going to happen if we graph this. It's going to hit the x-axis at 8 and 2, but nowhere else because the other two were imaginary. And if I go to all this work, doggone it, I'm going to punch it in and make sure. Let's see. We had x to the fourth minus 10x to the third plus 25x squared minus 90x plus 144. Should hit at 8 and 2 and nowhere else. Ta-da! We did it. We made it happen. That's what we want. So again, you guys were really good at this when we didn't have enormous nasty stuff in it. So I don't think this is going to be a huge deal for you. I am going to get you started on this fantastic little multiple choice looking problem here. while I get you a candy bar. See if you're doing the math right. So get started on that. Get your parentheses made, all that good stuff. Let's see, what are we missing today? I suppose I should stop the recording. What I heard people saying was, didn't we already do this? And yes, we did. I mean, on the test, you were really good at this and everything went really fast. But we also had a week and a half off for holiday break. So, P of x equals, if it's x minus 4, that came from x plus 4. 2i will come with its partner, a negative 2i. Remember, only the nasty ones come in pairs. And then that's going to be x plus 2i and x minus 2i. And like I said before, always go after the two that look like the ones you don't want to do first, because those will end up being nice. First times first is x squared. Outside times outside is negative 2ix. Inside times inside is plus 2ix. Last times last, minus 4i squared. Almost like a little bubble comes over your head. Wait a minute, I squared is negative 1. So that's going to make this x squared plus 4. And we still haven't done anything with our nice little x plus 4 yet. So all we have to do is FOIL, and we'll have this. So this will be x to the third. And then we'll have plus 4x squared plus 4x plus 16. And this one just happened to be multiple choice. They're usually not multiple choice, you know. But which one of these is a perfect match for what we have here? C. And there it is. This is what you're doing today. You are writing these polynomials from complex and or irrational zeros. So 4, 3, 2, 1, 0. Oh. Okay, so here's what I'm going to have you do, so you know not to get loud. I'm going to have you go back, say thank you to your partner, go back to your desk, hang on. Then we're going to go through one with the irrational zeros, because there weren't any examples, so we'll do one of your homework problems that has irrational zeros. So, make it happen.
Yeah, I think my mom would do that. On the dab, I saw that. I laughed for a solid 15 minutes. I was just crying with that huge laugh song. Oh, yeah. Wait, what page is this?
All right, for now, just take out a piece of homework paper and know that this is one of your homework problems today. And go right on the front there, right on the top, and then you can just do the rest of the problems below it. But notice this one has something that we haven't done yet. That 14 minus square root of 2 thing up there. It looks awful, but it's not bad. Not bad. So the first step is to recognize those cannot be the only two zeros. So if 14 minus 2, square root of 2 is there, what's the other one is there? 14 plus the square root of 2. And if negative 6i is there, what else is there? Positive 6i. Now here's where it starts looking scary. Because if these are our zeros, it's going to be x minus 14 minus the square root of 2, and x minus 14 plus the square root of 2. Like I said, it looks scary, but it's not. And then the one that used to look scary to us doesn't look any problem at all anymore. X plus 6i and x minus 6i. Remember before I said go after the ones that look the worst to you first? Put them out of the way? Yeah, let's do that. So, it is. There's a lot of parentheses, right? So I started thinking, gosh, that's really ugly. And there's a negative in front of it. Aren't we supposed to distribute that negative? Shouldn't we do all that stuff? Yeah, we should do all that. So let's distribute the negative. X minus 14 plus the square root of 2. X minus 14 minus the square root of 2. Okay, see your own, that doesn't look like fun. Am I supposed to take x times all the stuff in the red one, then negative 14 times all the stuff in the red one, then square root of 2 times all the stuff in the red one?
No.
I distributed the negative, Haley. Negative 14 plus the square root of 2. Negative 14 minus the square root of 2. Okay? So you try to think, how would be another way I could do this where I could use some math I already know, but not have to do 3 and 3. You could. You absolutely could do 3 and 3. But if we do this instead, it's going to make it a little easier. Because I want you to think about what happens if we take x plus 3 times x minus 3. What happens? They cancel each other out and there's no middle term. So wouldn't it be really nice if at least we could avoid a middle term with all this obnoxious stuff? So really what we need to do is first times first. That's going to be x minus 14 times x minus 14. We don't need to do outside times outside and inside times inside because they're going to cancel out. And we'll do last times last. Positive square root of 2 times negative square root of 2 will be negative square root of 4. What's the square root of 4? What's the square root of 4?
2.
Just 2. And I'm pretty sure we know how to FOIL something like that pretty easily. You know, it's got some nasty numbers with the 14 times 14, but it's not that big a deal. So P of x will equal x squared minus 28x plus, you remember 14 times 14? Most people know. Okay. 196. Can you tell me 196 minus 2?
Nope.
Now it doesn't look so bad. So it's all about regrouping it so that it doesn't look as obnoxious and scary. Now, if you said right away, you know what, I'm just going to do this Cedar home by multiplying x times everything in there, negative 14 times everything in there, square root of 2 times everything in there. Notice all those square root of 2's better cancel out when you do that, or you did something wrong. So it is easier to distribute and regroup when you do that. And then let's go after the other one, which is not so big and scary now. Right there. First times first, x squared. Outside times outside and inside times inside are going to cancel out. Don't even need to bother writing them down. Last times last is going to be negative 36i squared, which we will promptly change to what? Plus 36. Again, I put the short one in front. These numbers are bad enough. We're going to need a calculator for a lot of this multiplication. I like the short one in front. So now, we clamshell by taking x squared times everything back there, then taking 36 times everything back there. So P of x is going to equal x to the 4th minus 28x cubed plus 194x squared. Already done with the x squared. Everything has been done with that. Now I have to distribute that nasty 36. So plus 36x squared. And yeah, we're going to need a calculator to do some of this stuff here. So we've got 36 times negative 28. That is 1008 x. And then we have 36 times 194. That's going to be even worse. 6,984. Done? Very close. What's left? Just put the squares together. That's it. So p of x equals x to the fourth minus 28x cubed. We got 194 plus 36, which is a nice 230. X squared minus 1008x plus 684. Beautiful. There it is. Wait. Oh no. Which one?
This guy.
6,984. Big long number.
Oh, look at that. I didn't even write it down. I hope I said it. No, I didn't say it either. There we go. Just truncating it today, I guess. There it is. So, I do think that was the absolute worst of these that you're going to do. Actually, that was worse than what you need to do. So this is much harder than some of them I have for you. Oh, and I should point out, follow directions, because this is one of those assignments where 18 through 21 just says find the other roots. Don't write the whole thing, just find the other roots. So follow the directions, read the directions. So you're not doing the big long polynomial when you don't need to do the big long polynomial.
I did. I was in the first grade class. I remember when you came over. Yeah. I did. I was Scallions' first buddy.
Yep, we did one that was much harder than, you have 3 of them to do. And we did one that was much harder than those.
What are you guys? Where's the cow? There ain't no cow. Where's it take? Still use my
Catch up on your math this weekend. Test next week.
Oh, good one. Hey, you're bad. You're not gonna lie, that was actually scary.
180 test points remain. 80 points from the Chapter 5 test and 100 points from the final.
Yes. Oh, yeah. I literally